on pages 112 and 113 of our textbook. We're looking at graphs of logarithms today. You want to have your calculator and some colored pencils. Exercise 1, consider the log function y equals log base 3 of x and its inverse y equals 3 to the x. Well, first off, before we construct the table of values, let's make sure that this is the equation of the inverse. So to find an inverse, we switch x and y and solve for y. So I've taken y equals log base 3 of x and switch x and y. Now we want to get y by itself. Well, we are in log form and cannot do anything, so we will switch to exponential form. And remember, this is base exponent. So switching to exponential form, we have our base is 3, our exponent is x, and our answer is y. So yes, this is the correct inverse. Now constructing a table of values for y equals 3 to the x. 3 to the negative 2, that's the same as 1 over 3 to the positive 2, which is 1/9. 3 to the negative 1, 1/3. 3 to the 0, 1. 3 to the first 3, 3 to the second 9. So we have the exponential one here given to us first. Let's go over and plot these points. And I always like to have some unit numbers here. Before I start to plot. Alright, so using blue, 1/9, negative 2. That is totally incorrect. Let's try negative 2, 1/9. Negative 1, 1/3. So here's our increasing exponential function. Y equals 3 to the x. Now I'll switch to green. And now its inverse, we simply interchange our domain and range. So our domain here is now our range for our log. And range becomes domain. Plotting these points. Y equals log base 3 of x. So we have our exponential function and its inverse. We want to label the asymptote and its equation for each. For our exponential, as x goes out to negative infinity, y goes to 0. So this is the asymptote. This is a horizontal asymptote. Oh, it's down here. Let me put it here. This is a horizontal asymptote for our exponential y equals 3 to the x. So here's the asymptote. Oh, gosh. Going back. Good. So here's the asymptote. I'll try to do it with a dotted line. y equals 0, and now our vertical asymptote as y goes to negative infinity, x is approaching 0 for our log function. Okay, so it's graphed. Now our domain for our exponential function is our x's are all real numbers. Our range, all our y values are greater than 0. For our log function, this is switch, right? The domain is all our x's are greater than 0. And our range is all real numbers. Using a calculator, sketch the graph of y equals log base 10 of x. On the axis below, label the x-intercept and just state the domain and range as well. Okay, so y equals, we don't need the base 10, right? That's a common log. So we just press, in y equals, press log x. And our axes are going from, well, I'll just press graph, standard. If you want to adjust the window, you can to match what we have here. We'll go from -1 to 10, and the y's from -2 to +2. This is a nicer picture. X-intercept is 1. So estimating here. Domain, all our x values are greater than 0. Our range keeps going out and upward. This keeps going downward. All real numbers. The equation of the asymptote, this is a vertical asymptote. X equals 0. Next, we're going to talk about the argument of a log function. Because a logarithm of non-positive number, negative or 0, is undefined, we can find the domain of log functions algebraically by setting the argument has to be greater than 0. So we set the argument to greater than 0 and solve the inequality. The argument is when we're spelling out log base, it's the a, right? In this case, log base 3 of x plus 2, whatever follows our log base 3, in parentheses, this is our argument. So this piece right here must be greater than 0. So we say x plus 2 is greater than 0. Subtract 2, so x is greater than 2. Our domain, it's all x greater than 2. So our vertical asymptote would be x equal to 2. B, y equals log base 2 of x minus 3 plus 1. We take the argument, which is the x minus 3. Write the inequality. X minus 3 is greater than 0. Add 3 to both sides, so x is greater than 3. I'll go back. I noticed I made a mistake here. Hopefully you caught that and didn't copy me. Subtracting 2, we have x is greater than negative 2. And the asymptote would be x is equal to negative 2. Back to finishing up B, the asymptote would be x is equal to 3. Try C on your own. So the argument of any log function must be greater than 0. It's important to remember the argument of any log function must be greater than 0. Number 4, determine the domain of the following function. State your answer in set builder notation. Y equals log base 2 of 3x minus 4. We take the argument, the 3x minus 4. That has to be greater than 0. So solving for x, adding 4, and then dividing by 3. X is greater than 4/3. Set builder notation is a set of all x such that x is greater than 4/3. Pause, try B and C on your own. Remember in C here, when you divide by a negative, what happens to the inequality symbol? It switches. So x is less than 7. So that would, the domain is a set of all x such that x is less than 7. Which makes sense. If we put, say, 10 in here, we'd have 7 subtract 10 is negative 3. You can't take the log of a negative number, does not exist. And exercise number 5, using a graphing calculator. Alpha window number 5, sketch the graph of y equals log base 2 of x plus 3 minus 5 and its asymptote. Alright, so on the calculator, as it says here, alpha window number 5. So the green alpha, the window key, and then number 5, arrow down to 5, gives us log base and then our argument. So this is log base 2 of x plus 3. Make sure you arrow out of the parenthesis there, and then minus 5. Now, before I press graph, to state the domain, we know that our domain has to be all x are greater than negative 3. Right? If I take our argument piece, x plus 3 has to be greater than 0, so x is greater than negative 3. it says use an appropriate scale to include both intercepts. Alright, so a zoom 6 is my standard window. I can see that I have a y-intercept here, right? It crosses the y-axis between -3 and -4, but I don't see a x-intercept. So I'm going to double this. So I'm going to go to the window and go from an x max of 10 to 20 and see if that'll show up. It's close. But not quite, so I might go to 30 or 40. This was a Regents question, okay? So you have to be accurate here. As it says, use an appropriate scale to include both intercepts. I actually want to know, what is the x-intercept? So if I do second trace and x-intercept, remember another name for x-intercept is zeros, right? Press enter. It asks for a left bound, I'll press enter, and then it asks for a right bound. You need to move your cursor over to the right of where you think it may intersect. So I'm going to go almost to the end here. And then for the guess, you just press enter. Okay, so the x-intercept is at 29. Okay, so if we have to show an x-intercept of 29, then let's see. Let's go by 2's will not work. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Oh, we can go by 3's. That actually will work. So that was 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, and we knew that our y-intercept is between -3 and -4. So my x scale is going to go by 3's, my y is going to go by 1's. It is a sketch, it says. Right? But you have to make sure that we show both intercepts. Okay, so that was 29, about at the end here, close to the end, and between -3 and -4, and it looks like it's closer to, almost right in between there. And let's just look at the table of values for some of these negative values of x. We know that x is greater than -3. Okay, so -1, -4. Out there. And -2, -5. About there. I'm just labeling this asymptote there. Sorry, not asymptote. X-intercept. What is our asymptote? The equation of our asymptote is x equals -3. Our range, let me not forget, I need an arrow here. This keeps going downward. our range is all real numbers. So there you have, on the calculator, alpha window, number 5, log base. And thank you very much for your attention.